Hello, welcome back to the channel. In this video, we're going to be learning about the math class in Java. Now, a math class is part of a package known as the java.lang package. You should know that whenever you make your program, the java.lang package is imported automatically, and along with it, we get our math class into our program. Now, a math class has multiple methods and functions, but in all of them, 10 of them are really important and really useful. So in this video, we're going to be learning about those 10 methods. So in our 10 methods, the first method we're going to look at is known as the math.sqrt method. So your math.sqrt method is pretty simple. Let's just first try to understand the syntax. So your method, you're usually going to write it like this: math.sqrt brackets and a semicolon, and inside the brackets you're going to give a parameter, and this is usually going to be an integer value. So let's just give 36. Now what this method does is whatever value you give here as the parameter, it finds the square root of that value and it returns it. So in this case, since I gave 36, it's going to give me 6.0. Now I don't have to give it an integer value. I could also give it a decimal value. And even then, I will get the square root of that value. Now your first obvious question should be, well, if I'm giving 36, shouldn't I get 6? Shouldn't I get an integer value? What you'll notice is most methods of your math class return a double value. Now why is this? Because if you look at your input, this could also be a decimal input. And if it's a decimal input, I need to return a decimal value. Now you should remember from the syntax of your method that any method can return only one data type. Okay, I can't make a method return multiple data types at the same time. So what we decided is our square root method is going to return a double value. If I do enter an integer value and I get the square root as 6, it will convert it to a double and it will return the double value. So just remember this, it's pretty simple. This just makes sure that you can use a multiple variety of values and not just simple integers like 36. So now I just wrote this simple program where I have a variable a with the value 100 and I'm saying math.square-root 100. So you should expect your output would be 10.0. Again, it always returns a double value. And when I run this program, you'll notice that I get nothing. I don't get any output because when you say math.square-root a, it's only returning the value. It's just a getter method. And you should remember, you should always print getter methods if you want to display that value. So what we'll do is we'll just add a println statement to print that return value. So now I added this println statement, and when I run this, I should get 10.0. And if you look at our terminal, that is indeed what we get. So now I changed my program a little bit. I made a double and I changed the value to 6.25 to show that a method, a math.square-root method, also works with decimal values. Now when I enter a over here, I should get 2.5. So when I run this program, well, that is indeed what we get. So the next method we're going to look at is the math.cuberoot method. So our math.cuberoot method is quite similar to a math.square-root method. You're just replacing that s with a c. Now the function is also the same. Whatever value that you enter as a parameter, our math.cuberoot method returns the cube root of that value. So in this case, I entered n. The value that it returns is just cube root of n. And also remember, the return data type for our cube root method is also a double. Even if I enter an integer over here, something like 125, the return value is going to be 5.0. I do get a double value as my return data type. So if you look at this simple program over here, I have my variable a equals 8 and I entered a as the parameter, and it should return the cube root of 8, which is basically 2.0. So when I run this program, that is in fact what we get. We get 2.0. Now let's make the same changes. Let's make this int a double and let's make this 8 a double value and see if it works for double values as well. So as you can see, I changed my int over there to a double and I changed my value to 0.125. And now when I use this as my parameter for my cube root function, I should get 0.5. And when I run this program, I do get 0.5. So now let's look at our math.pow method. So as you can see, our math.pow method takes in two parameters, a and b, and it returns a double type value, the same as your first two methods that we learned about. It returns a double value, and this value is basically the first parameter raised to the second parameter. So in this case, if I enter 2 over here and 3 over here, it gives me 2 to the power 3. It gives me 8.0. Again, your return data type is going to be a double, just like your first two square root and cube root methods. Your return data type is going to be a double. So in this case, if I make this 1 power 3, it's just going to be 1. If I make this 5 power 3, it's going to be 125.0. So now let's just look at a simple program. Right, so as you can see, I have an integer called a which stores the value 8, and I printed math.pow a to the power 2, 8 power 2. So this should give me 64.0, and when I run this program, I do get 64.0. So it works pretty well. Now what we'll do is we'll again change the values of a first variable, and we'll try to enter a double value and see what happens. So as you can see, I changed that integer to a double, and I changed the value as well to a double value, 2.5. And when I run this program, I do get 6.25. So it works pretty well. Now something cool you'll also notice is you can use your math.power method as your math.square root or your math.cube root method. This is because when you take the square root of a value, it's just the value power 1 by 2. So in this case, if I say square root of 5, that's the same as saying 5 power 1 by 2. So if I have a equals 2.5 here, and if I have a power 2 and I want to change this to a square root of a, I can write this as a power 0.5. And when I run this program, I should get the square root of 2.5, which is 1.5811. It's a long value. Now we can also change this to 4.0, and in that case, we should get 2.0. And yeah, that is what we get. So now that we understood all of that, let's look at our fourth method, which might be one of our most important methods. It's the math.max method. And you use this a lot in your programs. So your math.max method also takes in two parameters. And as you can guess probably from the name, it just returns the greater value of those two parameters. Now the return data type for your max method isn't fixed as a double or an integer. It really depends on the arguments that you give or the parameters you give. For instance, if I give 2 and 3, it doesn't return 3.0, it returns 3 since both are integers. Now if I give it 2.0 and then 3.0, it returns 3.0. So the return data type really depends on your parameters. If you've given both integer parameters, it returns an integer value. Both double parameters, it returns a double value. So if you look at this simple program, I have a value a which is an integer, which is 5, b which is also an integer, which is 12, and when I do math.max of 5 and 12, it should return 12, not 12.0. Remember, the return data type depends on my parameters, and since both my parameters are integers, it should give me 12, the integer value 12. And when I run this program, we do indeed get 12, an integer. Now if I change these variables to doubles, you will see a different result. Now if I make both of them doubles, and if I run this program, I do get a double value of 12.0. Now I made a different change. I made the first value a double and the second value an integer. And when I run this program, you would expect to get 12, right? Because it depends on the arguments, and since one of them is the integer, the answer will be an integer. Well, no, what happens is this integer gets implicitly converted to a double. And you learned about implicit type conversion before. An integer gets automatically converted to a double. And so when I run this program, I get a double value of 12.0. And this is very intuitive, right? So if I make this a double instead, 12.0, and if I make this an integer and 5, I'll get the same result. I'll get 12.0. And this makes a lot of sense. Now your math.max method is especially important in for loops or while loops, where you have to compare values as you run your loop. We'll understand it later when we talk about arrays and other programs, but for now, you do know that you have a way of finding out which value is greater. Like your math.max method, there is another method which you use a lot. It's known as the math.min method. Now, our math.min method is quite similar to our math.max method. There, our max method returned the greater value. When we use the min method, it returns the smaller value. So in this case, if I replace a and b with 3 and 5, in this case, it will return 3. If I used max instead, it will return 5. It just returns the lesser value. Now, for the return data type, the thinking is quite similar compared to the max method. The return data type is the same as the parameters. So if I enter two double values, I'll get a double output. If I enter two integers, I'll get an integer output. If I enter one double value and one integer value, I'll get a double output because the integer is implicitly converted to a double. So now let's just look at a simple program. So if you look at this program, I have a double value 6.0, another double value 6.35, and I'm basically printing the minimum of these two values, and we know it's going to be 6.0, and since both my inputs are doubles, I will get a double output, and it does print 6.0, so it works pretty well. Now let's look at a simple method. It's also really important. It's known as the math.abs. So in a math.abs method, abs stands for absolute, and our input is just going to be one parameter. So what this method does is it takes in this parameter and returns what is known as the absolute value of that parameter. What an absolute value means is it just removes the sign of it. For example, if I have negative 3 and if I do math.abs of negative 3, this returns 3. Basically, even if it's a negative value, it returns a positive integer. It just removes that sign before that integer. So let's assume this is a real life scenario. You basically asked to find a distance between 2 points P1 and P2. They're both at a certain fixed distance and you just need to find a distance between the points. Now your first instinct could be, let's just subtract P2 from P1. And when you do that, it seems like it works. But remember, P1 could be greater than P2, in which case P1 minus P2 will work, but P1 could be lesser than P2. Let's assume P1 is 3 kilometers and P2 is 5 kilometers. We get negative 2 kilometers, which wouldn't work. Distance can't be negative. So I need to find a way to find a difference between 2 points while making sure the difference is always positive. And this is where our math.abs method comes in. So if you look at the program representation of that question, I have 2 points, point 1 and point 2, and I'm taking the distances as input and just measuring the difference between the 2 points. So point 1 minus point 2. Now before we saw that if point 1 was 3 and point 2 was 5, which is very possible. I mean, I'm the one who's entering the values for point 1 and point 2. Then I'll get a negative 2 kilometers over here, which just doesn't work. I mean, our distance can't be negative. So if we actually just try this program out, we'll just enter the distances for point 1 and point 2. So we'll say that point 1 is 3, point 2 is 5. It returns negative 2, which is obviously wrong. Now, how do we make sure that negative 2 is positive? We use the math.abs method. So we'll just say math.abs and we'll enter point 1 minus point 2 as our parameter for the math.abs method. So when we print this, we should get 2. The negative sign should be removed. So let's just enter in the same parameters, 3 and then 5. And we see that we get 2. So you can see that our program works pretty well. And this is not the only place I can use my math.abs method. This is just an example to give you an idea of how important it could be. There are multiple other situations where you could use the math.abs method. Now we do have 4 methods left, but they might take a little more time to explain since some of them could get a little tricky. So I'm going to make a part 2 video for that. Definitely do subscribe for that video. Thank you for watching and have a great day.